this is section 8.2, number 12. And in this problem, S, which is a relation, is defined on the set A, which contains four numbers, 0, 1, 2, 3. And S is specifically defined here. So 0, 0, 0, 3, 1, 0, 1, 2, 2, 0, and 3, 2. So there are six elements in S. The goal is to find ST, the transitive closure of S. In order, so what does it take for the relation to be a transitive closure of S? So it has to be transitive. That's the first requirement. That means, well, when after we found it, we need to make sure that each pair in it, it is transitive, right? So meaning if you have like A, B in S and B, C in S, then AC has to be in S, okay? So A, B, B, C in S, then this has to be, ST, because we are looking for ST. So therefore, make sure that this is going to be true. Now, second, the transitive closure should be like size-wise larger than this S, so larger than or equal to. So it will not be smaller than this relation. It will be bigger than this relation. Now the third is if there's another relation, let's call it L, whatever the relation L that contains S, like any other relation L contain S. Okay, actually another transitive relation. I'm sorry, that's transitive relation. If there's another transitive relation L that contains S, then the transitive closure, this special relation, the closure, transitive closure should be contained, should be a subset of L. Okay, in other words, this transitive closure is the smallest relation that contains this S, and at the same time is transitive. So that's what the very last one means. Now, how do we actually find the transitive closure? This is a good exercise actually for you. So the best way is to first let's draw the directed graph of this S. So I already drew it, but let's check it, okay? 0, 0, that means 0 and 0, 0. This pair is in the relation, so we do draw a arrow from 0 to 0, right? So therefore we have this one. 0, 3, so draw a arrow from edge from 0 to 3. And 1, 0, so draw an edge from 1 to 0, from 1 to 0, 1, 2, 1 to 2, 2 to 0, 2 to 0, and 3 to 2, 3 to 2. So there are, I think, 6 edges. If you count, there are 6 edges because there are 6 pairs. Now, let's do it one by one. Let's start with, say, vertex 0. So 0 goes to 0, and then 0 goes to 3. Okay, so you 0 goes to 0, and 0 goes to 3. Let's check. So here, does 0 go to 3? Is this already in the relation? Yes, definitely, right? 0, 3. So these two pairs actually show the transitivity, so that we do not have to add a new pairs into the relation. So let's check. So 0 seems like, and then the other one is 0 goes to 3, 3 goes to 2. Okay, so that means 0 goes to 3, 3 goes to 2. I see that. And then do we have a 0 goes to 3, 0 goes to 2 in our current inside the current relation? I do not see it. So therefore we have to add a, so to find the transitive closure, we have to include this into S, right? Because we want it to be transitive. So therefore we are going to add a arrow from 0 to 2. Okay, so this is new. Now, and then just seems like we are done with the one from starting with vertex 0. Let me start with vertex 1 now. So 1 goes to 0, 0 goes to 0. So therefore 1 goes to 0. We already have that, so we do not need to add new. So 1 goes to 0, 0 goes to 3. Do we have one? Do we have a pair that 1 goes to 3? I do not think so, right? So therefore we have to add this one here. Okay, again, why do we have to add this? It is just because we have 1 goes to 0 and then 0 goes to 3. Therefore, we have to add 1 goes to 3. So to the transitive closure. So that's why we draw that one. And then now let's take a look at another one. 1, so we check 1 goes to 0, right? And then 0 goes to 3. Now let's check 1 goes to 0, 0 goes to 2. Okay, do we have 1 goes to 2? Yes, we do. Okay, and then let's check 1 goes to 3, 3 goes to 2. Do we have 1 goes to 2? Yes. So it seems like we are done with, and you continue to check 1 goes to 2, 2 goes to 0, and we already have 1 goes to 0. So I think we are fine on all the, we are done with this vertex 1. So let's check the vertex 2 now. So 2 goes to 0, 0 goes to 0. We already have a 2 to 0. That's fine. So 2 goes to 0, 0 goes to 3. Do we have a 2 goes to 3? We don't. So therefore, we should add this one. So this is coming from 2 goes to 0 and then 0 goes to 3. Therefore, we need to add 2 goes to 3, right? So this is another one. Now, just repeat this process. By the way, sometimes it is tedious. So you can check 2 goes. We already checked 2 goes to 0. Now we check 2 goes to 3. 3 doesn't go anywhere, so we're in a dead end. And 2 doesn't go to 1. Seems like we are done with 2. Let's check. Start with vertex 3. So 3 goes to. Let's look at where it goes. Right. 3 goes to 2, 2 goes to 0. So therefore, we have to have a 3 goes to 0. We don't have it yet. So we need to add this one. So that means this is coming from 3 goes to 2, 2 goes to 0. That means 3 goes to 0. So we have gotten that. Now let's take a look at 3 goes to, where does it go? So 3 goes to 0, and then let's check. Seems like 0 goes to 0. We already have that. 3 goes to 0, and then 0 goes to 2. We already have 3 goes to 2. Now, and then let's check. 3 goes to, what else? Let's make sure that, oh, by the way, that definitely I see that 3 goes to 2, right? 2 goes to 3, right? So therefore, itself is another one. So 3 goes to 2, 2 goes to 3. That means we have to include 3 goes to 3. Similarly, I feel like I've forgotten for the 2. So take a look at 2 goes to 0, 0 goes to 2. So we need the 2 goes to 2. So 2 goes to 0, 0 goes to 2, and then we need 2 goes to 2, right? So this is another one. So we need to add another one there. I feel like that's pretty much all we have. Okay, you definitely can check. So therefore, that's all I can find. So therefore, the ST, which is the smallest closure, transitive closure, the smallest relation that is transitive that also contains the S. So this should be, well, I'm gonna copy everything from S. Okay, so which is 0, 0. Maybe I'll just do a little quick copying. So I'm gonna copy that. Oops. So copy that. And at the same time, add these extra 6 to the closure, to this relation, 2, 3, 3, 0, 3, 3, 2, 2. So that actually, this is the transitive closure.